Hello, good evening, everybody. And I have the sound on. And as you can see below, we have Mr. Jim Skipper and a new friend, Jeff. Don't know his surname, and obviously I wouldn't say if I did, and I don't know any other names he goes by. It's Jeff. He's got some interesting information he can give us, I'm sure. This is really exciting. So pleased to have Jim back again, looking fighting fit. I'm going to keep this intro short and sweet. I see we've got quite a few people in the chat already, which is great. As you can see, we're running video conferencing software, so some things won't work exactly the same as normal. I should still be able to see any super chats. I should still be able to see your chat, but I might be a little slower to pick things up than normal. So I'm going to switch on the desktop audio because I would never forget such a thing, and bring in our guests. Here we have Jim and Jeff. Good evening to you guys.
Good evening.
And how are you both?
I'm doing very well, considering. I feel, I had a busy winter time, I guess, and feeling great now, though.
Good. Yeah, because I think we last spoke before Christmas, and you said you were going to be busy until April, and you weren't kidding.
That's right.
And Jeff, I hope everything's going okay with you.
Pretty good. You know, we're hunkered down here in the U.S., waiting for the virus to go away.
Oh, man, yes.
And we don't have any toilet paper either.
Well, I did hear a story about in Australia where some guy took hundreds and hundreds of packs of 32 rolls back to a store and asked for his money back, and they refused him. Quite right too. Served him right, because he can't sell it on eBay. Anyway, for those of you out there who weren't around last time, Jim is a retired senior NASA test engineer for manned and hazardous missions. This man actually tested a Gemini spacesuit down to hard vacuum, which is something I would love to do. And Jeff, well, perhaps Jeff, you could introduce yourself. Tell us a bit about yourself.
I'm a planetary scientist. I've been looking at the moon and Mars for most of my career. Various parts of the geology, looking at terrestrial impact craters, and looking at hypothermophile organisms in Yellowstone.
Now, I've read a little bit, but perhaps you'd like to tell people what hypothermophile organisms are.
They're organisms that live in very high temperatures. In Yellowstone, some of the springs are at the local boiling point, and there are organisms right at the edge of the pool. And then as you go down the stream away from the pool, as the temperature goes down, different kinds of organisms populate the environment. So they operate at very high temperatures and very acidic conditions. I mean, some of the stuff is, a pH of 1.
Well, as I said, I did a little bit of reading, and I read about one type called strain 121, not because it's some secret number, but because it's happiest at 121 degrees. It can survive up to 130, but it can't breed at 130, or can't. What's the word? It can't go. It doesn't develop and split and whatever. But when it gets cool again, it does. Astonishing sort of organisms. So this could be connected with space, Mars.
Yeah, I mean, the question has been, could life have developed on Mars? And some of the earliest life on the Earth, apparently began around hydrothermal vents in the ocean. When you have a big impact crater, it's very hot for a long time, and so you can get a hydrothermal system there. So, you might have had local environments that persisted long enough on Mars for some microbial life to form, and presumably that would have gotten fossilized somehow. So we were trying to understand what the spectral properties were, what the light reflectance looked like, and how long it persisted after the organism dies, because anything on the surface of Mars now would be dead, and the question was whether there would still be a spectral signature.
Well, we're assuming it would be dead. What do you think, Jim? Do you think there's anything on Mars?
I mean, do you mean any life or anything still living?
Well, I guess either life or traces of.
A remote possibility. I think there's a possibility, but
it would be the most exciting thing to
it's hard
find
to
out.
say. Oh, it would be. Yeah.
Because that's one thing that gets me is people that say, "Oh no, there's no life anywhere else. It's impossible." Well, we've only got to find one cell that's not of Earth origin, one cell in one other place, and that's it. Game over. There's life everywhere.
Right.
I mean,
There's also a suggestion that there may be life. The satellite, some of the satellites in the outer part of the solar system, like Enceladus and Europa, presumably have subsurface oceans, and may have hydrothermal systems, and there might be life in the oceans.
All these worlds are yours except Europa. Attempt no landings.
Yep. That's right. But we're going to do it anyway.
Yes. I'll screw Arthur C. Clarke. But I mean, because that's believed to have an ocean below the ice, I guess it's the gravitational heating, or is it
in most
hydrothermal?
cases, like Io is very volcanically active, and Europa, and the reason is that as they go around Jupiter, the outer satellites sort of have this resonance where they're in the same place with respect to Jupiter's satellite periodically. So they form a line, and the satellite gets sort of squeezed like you're squeezing a tennis ball in your hand, and it heats up the interior. So Io has the most heating, Europa a little less, and the same thing is true in Enceladus at Saturn. So it's just a sort of squeezing like this that heats the interior.
And Jim, back in the 60s and 70s, what was the general thought in NASA? Did they think they were looking for life or just traces of?
Well, we weren't looking for that at all.
No,
it was someone else.
Do you think people felt it was there?
Not the people that I lived with in this area. Most people didn't think there would be life anywhere. This is down in the Bible Belt, and so they base a lot of their beliefs on their religion.
Yeah.
And although I'm strictly religious in some senses, I learned science before I found out that the religious folks didn't agree with a lot of science. Learned it when I was a kid somehow.
Yeah.
But no, at that time, I've heard people say there was no way to get into orbit. I think I told you I wrote a little essay in English where the first two guys who took off for space cracked the firmament. That was the last thing they saw was this gigantic crack going through the sky.
Well, just don't tell Nathan Oakley and that lot.
I don't remember what.
I said, don't tell Nathan. Oh, no. Connection interrupt. Can anyone see? Oh, are we back again? You're back, Jim. Jeff's back as well.
Okay.
Don't know what happened there. Yeah, I said, don't tell Nathan Oakley and that lot about cracking the firmament, will you? Oh.
Yeah.
I'm still getting...
Seems like there's a big delay maybe on the live feed.
Yeah, I'm not so worried about the delay on the feed. I'm more worried about you and Jeff disconnecting every now and then. Well, we'll have to carry on. Right now it's going.
Okay.
So Jeff, bearing in mind the sort of thing, you've been involved with, is there anything of particular interest or whatever you want to ask Jim? If you've been,
I was sort of...
Yeah, go on, Karen.
I was looking at some of the videos from the last time, and I don't know whether you covered it last time or not, but given the anniversary of Apollo 13, I'm curious what you thought about their sort of ad hoc way to keep the air clean in the spacecraft on the way back.
Well, we were involved in testing that to verify that it would work, because one of our chambers had the LIM ECS, the Environmental Control System, and our division chief was the one who suggested that swap to get the lithium hydroxide canisters out of one and hook it up to the suit hoses on the other one. So we verified that would work. And once I saw that they had a solution for that problem, for the CO2 removal, I basically ignored the fact that they were almost frozen to death. I didn't pick that up. We went on to something else, I guess.
That was a power, though, issue, wasn't it? That it was so cold?
I thought it was to do with the canisters, the scrubbers being different shape from the LEM, from the the other unit.
It was a chain of events. Yeah, it was a chain of the power that was lost was for the command module. They had power. They had batteries and power on the LEM, but they couldn't run the ECS, the blowers, to circulate the air in the command module because there wasn't any power there.
Okay.
And they didn't have enough canisters in the LEM to take care of 3 people for the entire mission, so they had to come up with a way to hook up the command module canisters, which were the little cubes with a hole down the center. And so they cobbled up, they used duct tape and some plastic wrapping, I don't remember, and a sock. And that did the job for the CO2.
So they got that generally right in the film then?
Yes. Looking back on it, you say, well, it was a very simple thing and obvious to do, but someone had to think of trying it.
Yeah, it's just
and it worked.
It is a shame, though, isn't it, that they never thought in the first place to make the canisters interchangeable. But I guess you don't expect that sort of thing to happen.
Right.
But as someone's just said in chat, the original square peg in a round hole problem.
That was mentioned, right. I saw that just the other day.
So, Jeff, you said you study craters. What does the study of the craters involve then?
Well, in the case of looking at the other planets, a lot of those craters are pretty uneroded and pristine looking, so you can understand what the structure looks like, how much stuff is ejected from the crater, and you could say, well, who cares, what happened on another planet, but the relevance is to the Earth, because the Earth was bombarded by as many impacts as the Moon, so the crust was broken up and stuff moved around, but the few craters we have here on the Earth are all pretty eroded. I mean, Meteor crater in Arizona is probably the freshest large crater we have. But
I've been there.
Everything else is...
The Barringer crater, absolutely phenomenal.
Yep. But that's only a kilometer across. It's tiny.
It looks big enough when you're there.
Yeah. Oh, yeah.
But yeah, there's some that there's just the traces of, isn't there? Absolutely vast.
Yeah, there's quite a few structures. Like there's one nearby us in the Chesapeake Bay, but it's buried under, hundreds of meters of sediment. You wouldn't know it was there if you went there.
So how was that discovered? Ground penetrating radar, or?
No, actually, they were drilling on the eastern shore of Maryland for water since the early 1900s, and there was always this layer of brackish water that they never could understand, and then a whole series of water wells and other studies finally indicated there was something there, and then there was some geophysics that were done, and finally the Continental Drilling Program drilled a deep hole there to see what was going on.
And they found what exactly?
Well, they've discovered what kind of materials were there, what happened, how old it was. One of the things that was of interest was it formed in an ocean off the east coast of the U.S. And the question was, did it have any effects on the environment? Like the Chicxulub impact killed off all the dinosaurs. And in this case, it's about 70 kilometers across, but it had very little impact on the environment. I mean, it killed off the local fauna in the water, but in terms of the long-term environmental effect, it didn't really seem to have any.
So you're studying the craters on Moon and Mars to learn about Earth, or is it the other way around, or is it both ways?
It's both ways. The other thing we use them for is we have a few samples from the Moon. We don't have any from the other planets in terms of trying to date things. And effectively, if you look at an area and you count the number of craters, the more craters there are, the older it is. and
I thought
so we try to use them that way too.
I thought they picked up meteors on in the Arctic, Antarctic from Mars.
They have, but we don't know where they came from.
I see.
On the planet. So in the case of the moon, we know exactly where they came from. So you can look at the area around it and count the number of craters and say, okay, in 3.5 billion years, you get so many craters. But if you don't know where the sample came from, you don't know what surface to look at. And we don't know where it is.
Sorry,
What's on Mars
can I just ask, Jim, is it possible, can you just try turning your volume down a bit? Not your mic, but your headphones, because your mic is picking it up, I think. We'll give that a go. Yeah? Oh, no. It's still coming. Don't worry about it. We had this last time.
Okay.
So, Jeff, I don't know if you've ever come across these people who say that with the moon, these people who they believe in flat Earth and so on. How can there be craters on this side of the moon because the Earth's in the way? Totally failing to understand the distance between them, and then saying, well, every crater is circular. Well, not everyone is it? But most of them are, because almost any angle it will make a circular crater.
Yeah, you got to get down to something very, very low angle before the crater becomes non-circular.
But there are some, aren't there?
Yeah, there's a few.
Yeah.
But if you think about, how big the moon is in the sky of the Earth, and how much of the sky it obscures, it's very, very little.
Yeah.
So it doesn't, the Earth would be a little bit bigger when viewed from the moon, but it doesn't hide much of the sky in terms of protecting the planet.
Someone has just asked, I think really, Jim, this is aimed towards you. Beyond launch, what's the most challenging thing in human spaceflight?
A re-entry.
Yes.
I turned my headset volume down. Does it affect the microphone volume?
It
affects
fine.
How I hear myself, but okay.
But it's I
the
can
re-entry
hear me back again. But don't worry about it, Jim. Don't worry.
Okay. Another re-entry. When you're in orbit or translunar orbit, I mean, sure, things can go wrong, but it's same thing with air travel, takeoff and landing.
Yeah.
You rarely run into somebody in the air. It makes a big thing. And there are instances of engines blowing up, so forth. But Apollo 13 was an example of sort of that kind of explosive thing. And there was a Hawaiian flight where the big section of the top of the plane blew off. So, no, generally the launch and re-entry.
Yeah, yeah. And of course, you're committed, you have no option. You have to re-enter. There is no other option, is there? You could delay for a while, whether that's hours or whatever, but after that, you've got to take that gamble. Because I think that with the shuttle that burnt up, they thought it was a good possibility, but they didn't tell them. Is that correct?
On the Columbia,
yeah.
the one that broke up over Texas,
because it lost heat tiles.
Right. Well, one of the leading edge of the left wing was broken. There's a spot broke out there, and so the hot plasma went in and melted the aluminum structure of the wing, and it fell off. So I don't know if they had been warned that was likely to happen, but there was nothing else that could be done.
No, exactly. Nothing could be done. So they could take no avoiding action. So why worry? Because they might have. Excuse me. They might have survived. I've just had a super chat from Mr. David Oliver, who super chatted £5. He said, I built the space shuttle in Minecraft earlier today to go with my International Space Station. Well, I hope you had fun, David. Oh. Well, there was go on, Jim.
I was just going to say that there are many airplane accidents that were similar. A jet fighter breaking the wing off a passenger plane, and are just collisions near airports, and the guys know they're going down and they're not going to survive, and that's just how it goes. That's part of it.
Yeah, it's part of it. That's what they accept, isn't it? Trying to do damnedest to avoid that sort of situation, but it's going to happen time to time. I've also been asked, where is it? What does Jim see as the biggest problem for going to Mars regarding long-term space person survival?
It may be the psychological difficulty of living with a small group of people for that length of time. And of course, the longer you're relying on a system that isn't easy to repair, the more the possibility that something can go wrong with it and you can't fix it. They are highly reliable systems, though.
And no doubt there's backups and so on. But you said living for some time. They were talking about a one-way shot, weren't they? With volunteers, go to Mars, don't come back.
Oh, I don't know. Who's talking about that?
I'm not sure. Is that part of SpaceX? It's one of those companies. Because obviously that would make the whole thing a lot cheaper.
Right. But I think it's very unlikely that they would even be allowed to do that. But besides the time and the problem of living with a group of people for that length of time, just reaching the surface, trying to establish a life support system there, and then launching back from the surface, it'll be a major job.
Certainly would. What about you, Jeff? Would you be interested in a trip to orbit, a trip to the moon, a trip to Mars? Oh, have we lost him? Might have lost Jeff again. If he comes back, we'll have to remember to ask him. Oh, he's still moving. Are you there, Jeff? Are you alive? I think he's alive. I don't know if he can hear us. Never mind. Oh, he's waving. Perhaps he can hear us. But your picture keeps freezing and we're not hearing anything from your end right now, Jeff. Oh, has he just come out?
How about now?
That's better. You're back again.
Okay, sorry.
Yeah,
I was just asking, Jeff, would you be up for a trip to orbit, to the moon or to Mars?
Yeah, I would go. Even given the risks, I'd go. I think it'd be really neat. I mean, I actually applied a long time ago, but the thought of living in Houston for endless time and only maybe getting to go is, in my mind, the downside.
Well, I saw recently they were asking for astronauts, trainees. Rather a lot of requirements to it, though.
Oh, they always get a huge number of applicants.
I bet they do.
I think just earlier this year they got a new class of astronauts selected.
Yeah, literally, I think finishing in the past month, they had a call open for people to apply. I mean, you did need a phenomenal amount of qualifications, and I think there were 2 stages of weeding just online via email or whatever before you even got to any sort of interview, or they looked beyond that. But I've had 2 more super chats. Cheshire Cat, a super chat, $4.99, saying, "I can beat David. I built an ISS replica in Kerbal Space Program." And then Crafty Keeler super chatted €5, saying, "I can beat David and Chesh. I had a vivid dream I was on the ISS once." Smiley face, smiley face. Yeah, well, I would go like a shot. My wife sort of said, "No, you couldn't. It's too dangerous. Why would you do it?" And I said, "It's just one of those things that I think you just have to accept the risk. You try and minimise it, but what an opportunity."
I mean, the Russians were
That's
offering trips.
probably.
I don't know if they still are anymore.
I think if you've got the money, they're up for it.
They're very expensive, I think. Yeah.
But they've been talking
But that's
about...
probably the that's probably the one big thing that I would probably do. I don't plan to take any airplane flights anymore or go on cruises, but if I had an opportunity to go into orbit, I'd take it.
Definitely. Well, actually, no, I'm going to keep it secret. There's an idea I had a little while back, but I can't progress it right now. But incidentally, I did read recently that they're talking about opening up the ISS to tourists at $35,000 a night. I presume that doesn't include travel to get there, though, because $35,000 sounds a bit of a bargain. I think I'd kick my wife out on the street, sell the house, and I'd have a couple nights up there for that.
I think that's just room and board.
Yeah. So travel would be a bitch, wouldn't it? Jim, do you think Mrs. Skip would be happy to see you go, or would she be glad to get you out of the house for a while?
Well, both. Yes, she'd be happy to see me go and be glad to have me out of the house a while.
And glad to see you back, no doubt.
Certainly. I had hoped that by the time before I retired and got too old, that they would be wanting people with my qualifications to go up and act as the ECS monitor and control person. They never reached that in time for me to be one to join up. I did have worked with a fella who's still at NASA.
Yeah.
He applied more than, know if it's more than to be an astronaut, but never made it.
Well, I mean, so few do. And then of those, so few actually get to go, don't they? I mean, Jeff, you said about if you applied about living in Houston. Any idea of the numbers and the do you know what I mean? Is it sort of like 5% of them actually get to go up, or is it lower than that? Or
I think now, since they retired the shuttle, the number is very low because you're only cycling them every few months, and of the 3 that go up on a given flight, at least one of them is a Russian.
Obviously,
yeah. The flight opportunities are very low, and at some level, there's a couple of people who have gone repeatedly because they're experienced and they know what they're doing. So I think there's a fair number of people who are just biding their time till we get a launch vehicle ready, so the number of U.S. people going up will increase.
Is that Artemis?
No, Artemis is. All we need right now is something like the Dragon capsule. We have a launch vehicle.
Yeah.
The problem is a human rated capsule. But Artemis, I think, is the lunar vehicle.
Right, because that's in several stages for building Gateway, orbiting the moon, isn't it? And then I think about mission 3 or 4 to then go down to the moon. Instantly, I've had a super chat from David Oliver, who super chatted £2. He said, "It's life, Jim, but not as Jeff knows it," which I thought was quite clever. And C4 said $2 saying, "Love you all, be safe, everyone." Yeah, I would definitely go if I could. So, oh no, we're not losing Jim. Oh, he's still moving a bit.
Oh, behind Jim.
Oh, there you are, Jim. You're back again.
Yeah.
Good. Thought we'd lost you. Right, well, I haven't heard from the other guy who said he might drop in. It really is a case of if he can fit it in. He's got, I think, 2 live streams tonight, and he was going to try and squeeze a visit in because I think he'd be quite keen to say hello to you guys, but I think he's up to his neck in it. So, Jeff, you said you studied the hyperthermophiles, which is sort of more biological. You studied the craters. So, are you a geologist or what?
Yeah, I have a degree in geophysics.
Geophysics.
Yeah. So,
is that the formation then? The formation of land?
Yeah, no, it's more like the interior structure and looking at the crust of the Earth through gravity and magnetics and seismic.
P&S waves.
Yep.
Oh, you should do a video on that. There's plenty of people who refuse to believe there's a core because we've only dug 8 miles down.
Yep.
Idiots.
Well, that and the moon rang like a bell for several hours.
Because there's only one geologist has ever been on the moon, isn't there?
Yeah, Jack Schmidt.
Yeah.
But, a couple of them, like Dave Scott, really got into the geology, even though they weren't geologists. Schmidt was actually a geologist, but people like Dave Scott really, studied and made really good observations while they were there.
Well, I mean, it's such an opportunity, and I guess that we're talking clever guys with a thirst for knowledge.
Yeah, I think some of them, though, looked at it as, just a mission. My job is to go to the moon, land, walk around, collect some rocks, and come home. And they did it well, but, I don't think they were particularly interested in the origin of the moon like, say, Jack Schmidt would have been.
Right. Well, I mean, if it's his
Right.
specialism, his training, his education. So, Jim, I actually saw you gave me a link earlier on to your page with your sort of annual visit. I think it was an annual visit back to the labs where you worked, and you showed this photos. I will see if I get the link. I'll try in a minute to hold a link for it, and I'll dump it in the chat so people can go and have a look. And now I'm losing my train of thought. I don't know why I'm saying this. Oh yeah. I was going to say, were you sort of pretty much separate, you and the guys you work with? Were you very separate from everyone else, or did it seem like a big team? I mean, obviously NASA is vast.
Well, yes, but our division was a big team. But because we were basically folks who ran the facility that certified systems were ready for manned use, we were a little bit of the competition for the rest of the division. They were responsible for getting the hardware developed and out of the contractor's manufacturing process.
Yeah.
And then we had to show that it actually would support life. So, in fact, our branch, I believe, is the only branch that I know of that has maintained the same name for something like 50 years. As programs shifted, we always needed the systems test branch because there were always systems to test, but they weren't always the same systems. I'm not sure if that answered your question, but we had there was a little bit of a rivalry between our branch and the rest of the division, even.
So places like Plum Brook, do you mean?
No, we focused on where we were.
Yeah.
Anything like Plum Brook or the Jet Propulsion Lab, those are just places you read about in the news. Very seldom did we interact.
Right. So you're given a job, test this, make sure that it does what it's supposed to do.
Right.
And what was the success and failure rate?
The Apollo backpack in its first configuration had all the hand controls on the bottom edge of the backpack.
Yeah.
So that meant the hand controls. I'm trying to show it on here.
Yeah. So reach around sort of the small of your back.
Yes, and they, the fellows had gloves on, but they had a thing to turn on the ventilation fan in the suit or in that backpack.
Yeah.
Had a switch with a handle shaped like a propeller. So how do you feel a propeller in a glove? Yeah. And that didn't work at all. They had to remote all of those controls to a little console. The shuttle EMU was in a much better shape with us, but you may or may, if you read what I've written online, you'll know that one of them burned up in the lab. because the 6,000 psi oxygen regulator was made of aluminum. And when you switched the valve on, you dumped 6,000 psi right on that aluminum body. They think there was a little drill edge left sharp, very small volume, and so the impact of 6,000 psi burned it up.
Just melted
And
it.
then later on, we found out that the waste ring, which was also made of aluminum, wasn't supporting the forces trying to pull the waste ring apart, the waste bearing. It was the waste, not the connector, but the waste bearing. So how? Okay, so the EMU has been operating for this, right, from 80 to 2020. So it's pretty successful.
Yeah.
Didn't kill anybody.
Well, that's a success, isn't it? It's like any landing you can walk away from is a good one.
All right. Oh, and I also have on my website the story of the first shuttle launch. I believe they only had one EMU. Back then, it was for an emergency egress to close the cargo bay or do something. And so they didn't have to use it. They landed. Our division chief said, well, let's run this through the vacuum chamber and show that if they had to use it, it would have worked. But it turned out the battery had died.
Oh, so that would have been a bit
Couldn't run it to
embarrassing.
vacuum.
Oh, dear. So they didn't test it beforehand then?
Well, it was embarrassing on the ground.
Yeah.
It certainly would have been
embarrassing if you were
flight.
relying on it. Yeah. A couple of people have seen your cat jumping around in and out the window, Jim.
Yes, I won't explain the cat, but if I lock the window, she'll get up there and beat on it.
Yeah.
I got a question for Jim. I was curious how
She's
they
a young one,
decided
just
on
been here a while.
the actual. Curious how they decided on what pressure to use in Apollo spacesuits.
It was a trade-off between worrying about pre-breathe. You don't want the pressure to be too low. You don't have any margin, and then the ability to make a suit that was mobile with the pressure. Seems like they're getting close to being able to have 14.7 with and get good mobility. The gloves are still the big problem. It's hard to put little flexible joints for each knuckle that will move easily at 14.7.
Because I guess the more pressure there is, the stiffer the whole suit gets then.
Yeah, and talking to Jack Schmidt and those guys, they had a hell of a time, with their hands trying to bend their fingers in that pressure suit, and their arms. They were really exhausted at the end of the EVA.
That's right, and the gloves were the main difficulty. They had pretty good joints for the elbow and wrist and shoulder. It took, all the way from Mercury on up into the shuttle program before they got all of that worked out. Or as much as they did get worked out of it.
Well, I'm just showing that picture. It'll take a while to get through, Jim. Showing a picture of you in the Gemini spacesuit. Because I saw some flat Earth idiot showing a close-up of astronauts and their gloves. And, of course, the palms, the inside of the fingers, and on, I believe, the Apollo gloves around the fingertips was all a sort of greyish, rubbery look. And it looked, just for that second, as though they were wearing fingertipless gloves. Totally failing to realise that it was more than one material. But I was looking at this picture the other day. Let me just adjust it a bit. And the glove there. What's all that? It looks like it's all duct taped up.
I haven't seen a picture.
Is it on the You're talking about the back of the glove in this area?
Yes, on the back of your left-hand wrist, it looks like there's loads of silver tape. Or perhaps you were just putting the glove on, taking it off, I don't know. But that glove looks very different than the other one. So do the fingers. But yeah, Jeff, that is Jim there.
Well, maybe it was.
Don't know.
To be honest, I haven't noticed it.
It was a little while ago, though, wasn't it?
The Mercury, yeah, but the Mercury suit was basically silver all over.
Yes.
I don't know.
It looked a bit more science
was,
fiction-y, didn't
a
it?
Mercury glove. I'd be surprised it would fit.
No, the glove looks the same as the right-hand
The
glove.
white,
But around the wrist connection, it looks like it's absolutely covered in tape.
they may have put some temperature sensors there and covered it with tape. I don't know. I could look at other. I think that's the only photograph. I have a 16 millimeter movie, 3 or 4 reels
Oh, wow.
of that vacuum run taken from the old
Jim.
black and white CCTV.
You should get that
Back on the
transferred.
shelf in my closet.
Get it transferred
I
to
can't
digital.
even get to it.
Get it transferred to digital, Jim, so it doesn't, it can't deteriorate anymore.
Yeah, no. Yeah.
Oh, there must be companies around that can do that.
But I don't believe that this particular glove, the Gemini suit glove, I don't think had the rubber-looking tips
Yes.
on the fingers. The gray-looking tips are
That's the one I was talking
a
about.
silicon rubber type of thing.
Was that sort of Apollo on?
And the suit hoses were a silicon rubber. The white fabric on the outside of the is kind of a fiberglass coated with Teflon and woven into that material.
Do you know how many
I'm not
layers?
a suit man at all.
No, but I just wondered, do you know how many layers of material it is? Because I believe the Apollo ones was something ridiculous, like about 18 different layers. So something like that. It was an awful lot of layers.
Well, it's online. It's at least 7
Yeah.
for this one.
And I think you were saying on your page that
For the shuttle.
the Playtex company who made bras were involved.
Right. It became International Latex, and they shortened it to.
Sorry,
And so by the time they were making these spacesuits, it was ILC
ILC.
Corporation or whatever. Yeah, International Latex Corporation.
I mean, Jim, I mean, I was...
Is anyone curious?
About what?
Anyone curious about why we lost the suit pressure in that very early chamber run? A lot of the flat Earth folks again say that was the only attempt at putting a guy in a suited vacuum, and we gave up after.
So there you go, Jim. If we could see your 16 mil film digitized, there you go. There's Jim. He's doing it. Booyah, flat Earthers.
Well, sure. Yeah. Yeah, and obviously these still photographs were made at ambient pressure during. That was pre-breathe, though. That was prior to the depress of the chamber.
Hence that other guy
Just
there with the
standing around
mask.
there for
I guess
2.5 hours.
That other guy was getting air at full pressure, was he? The guy stood with you?
Well, that was an oxygen mask. I don't know. Well, someone was in there taking a picture. Okay, so I know it was at ambient pressure. We didn't have colored TV in the chambers. So had to spend at least 2 hours. I know we eventually got up to 3 hours for the pre-breathe, but back then it was 2 to 2.5. So a lot of time, there was a lot of time before we actually started pumping the chamber to low pressure for the photographers to come in and take the photographs.
Yes.
So that's when those were made. My point being, you never see a photograph of me at vacuum.
Right.
And it's not because we're keeping it secret or anything, but you couldn't get in there. Yeah, they could have come to a porthole in the chamber, and I used to do that some myself. Take photographs through the porthole. Looks the same in the vacuum as it does with air.
Well, not according to some of them, because there has to be ether. The light can't propagate in a vacuum. That's what I've heard some of these idiots say.
Need ether.
Yeah. So I said, well, that means if you have a vacuum chamber, even one with a porthole, you won't see the other side of it because the light can't get to you. Idiots.
Oh, because there's so many people online now who have little vacuum chambers at home. They're made of plexiglass.
Yes.
And they pump those things down and do all sort of weird tricks in there. Interesting things. Let me tell you about the suit failure.
Yeah,
Ready?
Please do, Jim. And
we
then
were transitioning. Okay.
No, I was just going to say, and there's a question for Jeff. Perhaps you can have a think about it, Jeff, because someone's just asked, do the moons are due to have similar composition to Earth? Do they have tectonic plates? Or are they made more of one cold, solid substance? Perhaps we can let you have a think on that while Jim tells us this suit story.
Okay.
Yeah, go ahead, Jim.
Okay. We were transitioning from, what was that, Gemini to Apollo. They had increased the diameter of the suit hoses. You can imagine a 2-inch diameter suit hose at 4 or 5 psi. You got like 15 pounds of force trying to separate that hose from whatever it's connected to.
Yeah.
Who work on their automobiles and change radiator hoses know that you got to slip the hose, or any hose fitting over a metal piece, have to slip over a ridge, and you clamp it down behind the ridge. Okay, so we had the Gemini facility that had aluminum tube with that ridge on it, but the Apollo suit hose was too big to go over and clamp it down. Someone said, hey, let's get a piece of Tygon hose, slip that over the small metal tubing, and then the silicon rubber suit hose would slip over that, clamp it down, you do fine, except that now you lose the effect of that ridge at the end of the metal pipe.
Yep.
And then the suit was moving. Suit hose, as the guy exercised, moved up and down, and it slipped around. And that's how he was exposed to vacuum through a 2-inch hole.
And that's the guy who claps backwards.
Yes.
Yeah, and then within seconds, the guy in the other chamber. So he'd have been down at partial or very low pressure. Is that right? So you have a guy waiting at low pressure.
The one in the... Yes. Well, let me mention he was waiting at what we called 15,000 feet.
Yes.
That was a lock pressure.
And then
equivalent to 15,000 feet.
So is the term that they repress the main chamber?
Right. Emergency repress. And normally takes 30 seconds.
And then the guy from 15,000 feet can get in because it's the same pressure. It saves them getting all the way up to atmospheric.
At that point.
Yeah.
And then it continues.
You said it continues and you stopped dead in the stream. Oh no, Jim's dropped out. Oh no, they've both gone. I hope you guys are still getting... Oh, he's back again. You're back again, Jim. Oh. Jeff is back. Oh, hopefully you'll have Jim back. Oh, Jim, you back?
Yeah.
Sorry, it dropped out again.
I hope so. Yes. I see myself.
Yeah, but remember there's a delay there. Never mind. We were just talking about it. So they repress to 15,000. The guy dashes in, and then you said they continue pressurizing back up to atmospheric.
Yes, that's right.
And he was all right, of course.
He was all right. It's possible that maybe one of his eardrums was ruptured, but they healed pretty quickly.
Yeah, yeah.
He didn't have any lasting problem with it.
Good, good.
People ask me, how do you get the chamber to go up to 15,000 feet?
Oh dear. Well, as in up.
Seriously.
Oh no.
Yes.
Oh.
Well, every endeavor has the special jargon that confuses people who aren't in on it.
But yeah, but
It's just normal.
I'm not in on it, but it seems obvious. Yeah, we'll get the pressure down to what it is at 15,000 feet. So we're taking you up to 15,000 feet. It seems quite obvious.
Yes, to the technical minded, maybe the housewife. I think this was probably some woman that we were talking to.
Oh.
And they're technically minded women. I don't want to get into that problem.
Oh. Well, what about Jeff? That question.
Not so many back in the 60s.
No, but a different world, wasn't it? Jeff, that question someone had to you. Sorry, it scrolled off my screen. It was about.
No, I was looking at it myself.
Yeah.
So, Jupiter's got like 80 moons right now. The bulk of them are just little tiny rocks that'd be similar to an asteroid.
So just solid.
Just made out of rock.
Yeah.
Yeah. Io is Io and Europa are about the same size as the moon. Io is solid rock in the sense that there's not a lot of water ice. Has a density similar to the moon, but because it gets squeezed by the gravity field, it's very hot, so it's continuously erupting volcanoes, and the weird orange color is because it's sulfur that's being erupted a lot and gets coated. Io is mostly just rock.
Was it from Io that they got that photo of that eruption on the horizon line?
Yeah.
Okay. Because that's huge, isn't it?
Yeah, they're huge, and that was no one was even looking for those.
No.
When Voyager went past, one of the things they were doing was just trying to determine the size of the satellite. So they had a program that would fit a circle around the picture, the ball in the picture, and it wouldn't work for a bunch of the Io pictures. And so somebody finally looked at the pictures and said, "What is this funny bulge on the side?" And then they went back and looked and figured out what was going on. Europa, as I said, is about the same size as the moon, but Europa is much lower density. So the model is that it has a rocky core with a water ice and a water mantle, if you will, and then an ice crust.
Yes.
So it's sort of, not really, but like 50-50. When you get out to Ganymede and Callisto, they're both very low density. They've got a small rocky core, but the bulk of it is water ice. And presumably both of them are cold enough now that it's solid ice. But if you look at Ganymede, it's got all these funny broken up plates that kind of look like plate tectonics in the sense that pieces have broken up and floated apart. So there was activity.
So, sorry, I'm just struggling to remember which one. That's the one that looks like broken up ice flows that have refrozen. Is that the one?
Yeah. Got these big, long, bright grooved areas, and then these darker cratered areas that, if you take the grooved areas away, fit back together.
Yeah.
Like a puzzle. So, and then when you get farther out in the solar system, they become more and more ice.
So what about nearer? Mercury, I presume, is just going to be rock with perhaps a molten core, but Venus, would that be likely to have plate tectonics? Do we know that it has plate tectonics?
It doesn't appear to. Venus has an atmosphere, so the only way to observe it was to do it with radar.
Yeah.
So a number of years ago, they sent a spacecraft to map it with radar. Some of the surface is very young. There's lots of volcanoes, but there's no obvious plate tectonics where stuff is moving apart and areas where stuff is compressing together. So if there's crustal recycling on Venus, which there must be at some level, it may just be kind of vertical. Lava comes out, buries the crust, and it just sort of
Because otherwise you'd get rift valleys and things like that.
Yeah, the only place that really has those is the Earth.
Super chat. Excellent.
There's some suggestion on Mars that there's this giant canyon runs across the equator called Valles Marineris.
Yes.
Which is presumably an extensional feature, but there's really been no large scale movement like there would be in a rift valley on the Earth.
The Valles Marineris, is that the biggest canyon in the solar system that we're aware of? Sort of stretches for thousands of miles, doesn't it?
Yeah, it would be the equivalent of all the way across the U.S. and if you were to stand on one side, you
couldn't see the other because it'd be beyond the horizon, wouldn't it?
Well, I mean, assuming it's not flat, but yeah.
Oh no, we can't talk about flat Mars now. Oh, that'll blow or bake their noodles, won't it? David Oliver has super chatted again saying, is most of Jupiter's moons cryovolcanoes erupting molten ice? Water? ? Well, you mentioned sulfur.
Yeah, Europa's surface is very young. There's got to be active processes. They can see some geyser-like activity along the limb. When you look at the planet against the sky, you can see some bright stuff.
Yeah.
So there's some kind of process going on, and it's water. So yeah, you can call it cryovolcanism. It's not. I don't know that they've recognized a cryovolcano per se with water flows coming out that turned into ice.
So is that just a cleverly made up term then?
Cryovolcanism?
Or is that a thing?
No. I mean, we don't really have it on the Earth, but it's not it's how they describe it is cold volcanism. So you're using something that would melt at a low temperature, so water.
Right. Well, another super chat's just coming from Anthony Purcell for $5 Australian, saying, geophysicist here. The theory is near-surfaced Venusian mantle has too little water content to be deformable like Earth's.
Yeah, no, that's a plausible idea. I mean, in the Earth, the subduction zones bring a lot of water to the mantle, and one of the arguments is that you need an ocean to have plate tectonics.
Is that lubricant? Is the water acting as a lubricant as well, or is it just?
It affects the melting point.
I see. Okay.
And the viscosity.
So, Jim, you obviously spent many years working with the testing of equipment and so on. But did you follow and have much of an interest in the science side? I don't mean that in any sort of belittling way, or were you just wrapped up in the challenge of doing your job, or were you excited about the things they might discover as well?
Well, I was excited about the things they might discover, and I was excited about plate tectonics because when I was a little kid, to ask the school teacher why South America and Africa fit together, they said, well, it's just a coincidence. And so in the early, I've followed Scientific American, I've subscribed to it for 50 years now.
Yeah.
So, I'm interested in the general science as well as specifically related to space travel or space exploration.
Well, I mean, things have changed over the years.
And I got to go to Barringer Meteor Crater too.
It's beautiful, isn't it?
Yes.
I mean, I went to the visitor centre and I touched that there's that largest piece of the meteor that they found is there in the visitor centre, and I touched that. And then they took us on a walk around the rim, I think about a third of the way round, something like that. And then they were doing as a photo opportunity. You could stand on this little ledge with a crater behind you, and someone would use your camera to take a photo. And I was doing that. I'm terrified of heights. So I had this photo, and then I thought, what the hell am I doing here? But it's like the idea of going into orbit. I'd be absolutely terrified, but you'd have to do it because the opportunity is just too great to miss. And that's how I felt at the time at Barringer.
Well, the neat thing is it only took 10 seconds to form.
Yeah, but have you heard what some of these people say? Well, where's the meteor then? All these craters and no meteors. They seem to think it'd be
Well,
like a stone you're dropping into wet mud and plop, there it is. Just, I mean,
that was
it
actually
just ionises, doesn't it? Pretty much.
yeah. Well, it gets broken up during the impact event, but Barringer um, thought it was that way. He assumed there was a big piece of iron under the floor, and so they did a bunch of drilling. And if you remember when you were there were these little white spots on the floor. They dug shafts down there looking for this giant piece of iron, and had it been there, it would have certainly been economical. But it's kind of a neat history because as people began to understand how fast the stuff was coming in, size of the thing got smaller and smaller and smaller. But Barringer never believed that. He thought the scientists were all nuts, and that somewhere down there was a big piece of iron, and it was sort of complicated by the fact that there's a geologist from the U.S. Geological Survey, Gilbert, who went there. He thought the same thing, so he measured the volume of the crater and calculated the volume of the ejecta and figured out, well, if you take all the ejecta and put it back in the crater, it evens out. There's nothing missing.
Well,
So they didn't think it was. There was a lot of discussion early on about what it was. Some people thought it was a salt dome. Some people thought it was a explosive volcanic vent. But everybody thought there was a big giant piece of iron down there originally.
well, someone just said it was an airburst meteor? Question mark. It wasn't airburst, was it? It's just it's like a nuclear explosion, basically, isn't it? The whole thing would be just minuscule bits of shrapnel. Isn't the whole area covered in tiny little, almost ball bearing like things from the molten? Is it buck? But do they call them
Yeah, and
buckyballs?
it's basically the projectile just gets destroyed in the impact. There are some big pieces, like the piece in the museum.
Yeah.
There's some pieces in other museums. Early on, all of the sort of softball and whatnot size fragments were all collected. So the only thing you find now are these little tiny, ball bearing
Yes.
size pieces around.
I did try and have a look for a piece when I was there, but nothing. I guess it's been pretty much picked over. I'm trying to, as we're talking, I'm trying to have a flick through some of my photos to see if I can find this photo of me there. But the chance of me finding it are pretty slim, actually. Going through all my, because I think it's about the year 2000 I went, but I absolutely loved it.
There's an interesting story. I don't know if you noticed it, but on the floor of the crater, off in one corner, there's a little piece of silver something.
Aircraft?
Turns out yes, it is. There were some commercial pilots who were flying back and forth across the U.S. and noticed this thing. So apparently a couple of them rented a plane and flew into the crater. But because it's so windy, you often get a situation where you can fly around in the crater, but you can't get out. And they wound up flying around until they ran out of gas and landed on the floor.
Yep. They told us that story and pointed it out when I was there. It almost sounds unbelievable, doesn't it? Now, I've actually found my Arizona picture, so I'm just oh, here we go. Let's see if... There we are. How about that, then? Let me see if I can move the picture around a bit. So this was about 2000. It'll take a while till it gets through to you on the stream, but that was quite a drop beyond me. Because I think the Washington Monument can stand in the bottom of that and be flush with the surface. Is that about the scale of things?
Yeah, that's about right.
I don't know if that picture's come through to the live stream yet.
I haven't seen it. There it is.
Mm-hmm.
Let's see. I've got a picture to the right as well.
Yeah, you can see those little. You see those little squares on the floor there?
Let's see if I can.
Little bright spots.
Yes. I'll
Those are where, and then there's that real bright one just by your left elbow. That's where they dug the shafts, and the white one. There's still an active shaft there that's been cribbed so that you can actually go down in it.
Wow. But there's some sort of huts or something in the middle, isn't there? Because didn't they do Apollo training here as well?
Yeah, the dark stuff on the floor is there's a big old compressor that they used for running the drilling operation. So that's that big black thing you see.
Yeah. But of course, visitors aren't allowed down there now, are they? Because of the erosion. I think isn't it only scientists are allowed down there now?
Yeah, there's and even that it's pretty restricted because they don't want people screwing up the crater and because of the erosion.
But it was absolutely stunning. I loved it. And I arrived there the day after I'd just been to the Painted Forest and Painted Desert and Petrified Forest. Beg your pardon.
Forest,
yeah. It was a wonderful trip. When were you there, Jim?
Maybe in '82. I don't remember for sure, but they had not blocked the trail around the rim at that time, or they weren't monitoring. I'm not sure. So my wife and I hiked the whole way around.
Okay, yeah, we could only go, as I said, about a quarter to a third of the way, maybe.
Right.
So as I'm stood there, if that's at 6 o'clock position, the visitor centre is probably about 3 o'clock. Probably about 9 o'clock position to my, round to my right, the right. The left side of the picture, my right in the picture.
I'm sorry.
So if I'm stood facing the camera, facing 6 o'clock,
yep.
The visitor centre is probably about 8 to 9 o'clock.
I'm not actually sure which side of the visitor center you're on.
Okay, if you stood facing the visitor centre with a crater behind
the west side?
I don't know which side it's on, but if you've stood facing the visitor centre with a crater behind it, we went anti-clockwise around.
Oh, okay, all right.
Yeah.
So,
the
when I finished that photo op, we then went back clockwise.
Yep.
And if anyone gets a chance to see it, I thoroughly recommend it.
Yeah, it's spectacular. Particularly if you really understand what happened. Otherwise, it's just a hole in the ground.
I mean, I'd agree and disagree. I'm sure that you'd get a lot more out of it if you understood about it. I mean, there was some stuff in the visitor centre, so I learnt stuff while I was there. But even without it, it's just awe-inspiring. Not quite the Grand Canyon scale of things, but it's still phenomenal.
There's another crater in Texas that is thought to have formed at the same time. They're both formed by iron meteorites. The one in Texas is much smaller, but the thought was they were both part of the same event.
Oh, right. What, a breaking up of something?
Either that or you had a couple of bodies traveling together. But the meteorites are almost identical.
What, just by the remains that they found, you mean?
Yeah.
Because I know I'd lose track of them all. Because it's what, chrondites? Is that stony ones? I don't know.
Chondrites.
Sorry.
Yeah. No. Well, there's chondrites.
Chondrites.
Basically, there's stony ones and iron ones. The chondrites have these little pea-sized things in them called chondrules. So,
pebbly bits, are they?
Yeah. I mean, they're small and they're sort of mixed in, and presumably they represent some really early material from the solar system formation. Because apparently they're not very processed.
I see. And not processed through a cycle on a planet or anything like that, you mean? Heating, cooling, squishing and pulling and goodness knows what else.
Well, they got mixed into whatever is now the meteorite, but they're the most primitive material that we have.
Because they're formed and then unchanged for billions and billions and billions of years. Yeah.
Yep.
Do you find this sort of stuff fascinating as well, Jim? Have you got a general thirst for anything?
Carbon.
Oh no, it's just locked up again.
Read something about.
Sorry, say again, Jim, please.
Meteor firmament.
Yes, sorry. Sorry, Jim, you're just breaking up. Can you try again?
meteorites.
We're getting some technical problems here again, I'm afraid. Are you still there, Jim?
Oh yeah.
Good. Yeah. I don't think you're doing anything wrong, Jim. Thumbs up to you.
I'm still here.
It's just the internet connection's a bit flaky. I think we've had that more and more lately. When I've been watching some stuff online, the picture quality's gone down. It's just so much strain on the internet.
I mean, it looks fine here on the website, but not on the YouTube.
Never mind. We can only work with what we've got. I was watching a program only a couple of nights ago, Jim, and it's actually quite a fun series on Netflix called Timeless, something like that. It involves time travel. Each episode they go back to a different period in time, and they went back to Armstrong's moonshot, and they actually broke into the computer centre. And there's a lady there boasting about the computer having 2 megabytes of memory, which just sounds crazy. But I mean, my phone is 16 gigabyte. That's nothing. I don't know what my computer is. A 250 gigabyte plus a terabyte, and yet PCs were just 640k. That's all you ever needed. That's what things move on so much over the years. I think someone actually asked you, what's the biggest surprise you've seen with the ongoing development since you left?
I think I'm surprised we're still using the shuttle spacesuit system after 22 years. But the smartphones where you have camera, phone, computer, all the things, and you need the memory because of all the applications that can be done with one device. Those early computers were basically dedicated to doing one thing, and if you needed something else, you got another computer to do that. At least that's my opinion. I was just amateur at the computer systems. I could use them. And we recorded data on a big giant vacuum tube type computer.
Yes.
Long before we had desktop units in our offices, we had that big data system.
Well, I started off working on
a Wang computer.
Wang, yeah.
Yeah.
I mean, I started off working on mainframe computers, but the thing is, it was all green screen. You didn't have pretty colours and little scroll bars and things like that. There was nothing. Everything was just keyboard. So it didn't need that sort of memory. And programming, I know right from when I started programming, you had to be concerned about the efficiency of your code, not waste memory. You'd write things in a clever way.
Right.
Now you don't need to worry about it. You can just chuck some more memory in, chuck some more disk space. Who cares? It's as cheap as chips.
When I was in the university, who was first there? I'll be quick. Our computer had a drum memory, and you tried to pick your location so that you didn't have to go around an additional turn to get to the location you wanted to pick up. Okay, Jeff.
I was just thinking the first Mac I had 1K of storage space. I'm thinking, how could you possibly fill that up?
Right.
Well, I bought a computer in 1995, and I paid an extra £100 to upgrade from 850 megabytes to 1 gigabyte disk drive.
Wow.
I know. I splashed out
terabyte drives for $100.
Yeah. My daughter came down with a little terabyte thing. It was no bigger than my phone. Just plug it in USB, and it's a terabyte solid state disk drive. Absolutely incredible. It's just gobsmacking. Wow. I mean, I worked with big disk drives that really were disk drives, hard disks, sort of 10-inch, 12-inch disc, 10 platters, and it was a thing the size of a small fridge. And you'd actually screw it in and then get it up to speed, and later on switch it off, wait for it to slow down, put the cover on, screw it up, and change with another 80 megabytes. It's just unreal.
Those were the old VAXs.
I'm sorry?
Those were the old VAX computers.
Well, it's actually ICL, but they were very, very similar, yeah. And also reel-to-reel tape. I loaded my first job.
I remember when during Voyager and Viking, trying to do image processing of the pictures that were coming down and doing it on those kind of machines, and it would take forever to do it, and you'd have to load tapes and change those disk drives out. Now you can do it on a PC in 2 or 3 minutes.
Yes, and I mean the baud rate coming back from Voyager is something like, I forgot what it is.
Well, now it's almost nothing.
Yeah, because of the distance. Yeah.
But even from Pluto, it took them months to get all the data back because the spacecraft was pretty small, and the antenna was pretty small, and so they were just dribbling the data down, over a really long period of time.
Yeah. And I wonder how many packets they have to... I'm not sure of the format, whether they actually use packets or whatever, but how many bits they had to repeat because of signal degradation.
I don't know that.
Because that would slow it down as well, of course.
Yeah.
Cheshire Cat's just said he's got 18 terabytes total on 5 drives in his PC. 18 terabytes. What have you got on there? The entire internet? Oh, man. So what's next then? What's next in NASA then, Jim, do you think? We got Artemis planned over the next, 4 years, 5 years?
Well, that's what's next. We got to get a way to get somebody back into space using our own spacecraft, and that hasn't been assured yet.
No.
I've probably told you when they announced the shuttle was going to be discontinued, I said, well, it'll be 2020. Actually, I was thinking 10 years to get a man-rated spacecraft ready to go, because we're starting from zero almost. I know there's all the technology and the knowledge, but you still have to put it together and make it work as a system and verify it. So it's a big job. They're finding that out. I hate that things have blown up, and they had program timers that made the launch miss the space station. So they got to sort all that out, and it just takes time. Once you have a problem, it takes minimum, from my experience, to figure out, get it corrected, and then convince someone that it is correct and ready to go again. Look at the Boeing 737 MAX, isn't it? It had that software problem
with the nose dipping. It takes
time. Yeah. So it always took 6 months to a year for us to recover from a problem of that sort.
Of course, I understand with the 737, it's actually inherently unbalanced because of the wing, the engine size and position. So they were having to use software to try and counteract that. That's what I read. I'm just. Yeah, what I don't know is why. I mean, don't get me wrong. I want to see us on the moon. What a fantastic thing to see. But do we really need to go to the moon first, or is it practice? I just want to get us onto Mars. That's what I want to see.
I think it's a couple things. It's as Jim mentioned earlier. You've got system issues that are very difficult to repair once you're on your way. So one of the thoughts is to use the moon as kind of a rehearsal, if you will. You could put whatever vehicle you're going to use to go to Mars, you could just put it in lunar orbit. If there's a problem, you can go. If it were crewed, you could go there and pick them up. Even if it wasn't crewed, you could go there and find out what the problem was, and get all that redundancy understood before you go off to Mars. There's also surface operations that you would use on Mars that you could test on the moon. The environment's a little different, and there's the science of the moon, and there's also an argument about using lunar resources. Presumably, there's all this ice in the permanently shadowed craters at the poles, and the argument is that you could use that for fuel. The problem is we don't know what form it's in. We don't really understand how much it's going to cost to get it out, so the break-even point is not clear yet. But there's lots of, aside from the moon in and of itself, there's lots of reasons to practice and demonstrate stuff in the lunar environment before you go off on a one-way trip. The worst situation you would have would be something like Apollo 13, where you have to go all the way there and come back without actually landing.
Yeah.
And you're talking about a year, not a few days.
Right.
But of course, if you
Yeah.
I mean, I can certainly understand the practice thing. As I said, I would love to see us go to the moon anyway, but I just would love to see us on Mars even more so, because the idea of using, because it's Gateway, isn't it? The lunar orbiting station that they're talking about or are planning to build. So it's called Gateway.
Yeah.
If you travel to Gateway, you then in effect get yourself down to you've made that journey, you've gained all that acceleration, you've got rid of that acceleration or that velocity. You're going to have to build velocity again to get back. If you want to go on to Mars, you're not just headed straight off there, or you're not slingshotting around the moon. You're just almost coming to a halt and then starting again.
No, it's not really that bad. I mean, you can imagine going into Earth orbit, before you went on your way somewhere. The biggest cost is, just getting out of the gravity field. So I guess in some sense, if you wound up getting out of the Earth's field and going down into the moon's a little bit, there would be some loss.
Yeah.
But the argument is that if you're going to go to Mars, you need so much hardware you couldn't launch it on a single launch. So you got to put it together somewhere. And
I suppose also if you are able to synthesize fuel somehow from materials on the moon, there's a big gain because you're not lifting that from the Earth.
Yeah, that's correct. You don't have to have the Gateway. You could do it in Earth orbit, or a lower lunar orbit. I mean, Gateway's out at the Lagrange point. So.
Oh, is it? I didn't realise. I thought it was actually in orbit.
No, I think that's my recollection. I haven't looked at it in a while.
No, I don't know off the top of my head. I'm not going to look.
I'm not sure. I think at one time they thought of assembling the lunar mission stuff in Earth orbit, but that was long ago. I haven't looked at it lately, at the history of it.
Well, Jim, you mentioned about the psychology of living with a bunch of people. Now, someone's just asked about our opinion, all of us, our opinions on rotating spacecraft to recreate artificial gravity for the Mars trips. Obviously, if you spin them at the right speed, you've got 1G, and potentially you could slow it down gradually on the journey so that you achieve a Mars gravity, an artificial Mars gravity by the time you get to Mars, and coming back the other way, you could slowly speed it up to reacclimate people to full Earth gravity. Would that be different, do you think, psychologically, if people could walk around rather than floating around? Quite apart from the fact that your bone density's going down and all the other issues with zero gravity, or microgravity, I should say.
I'm not sure. Yeah, I'm not sure that psychological difficulties of living with a group of people in such a small environment would be helped with 1G, but being able to simulate a little bit of gravity would certainly help with exercise, and I think make folks more comfortable. It would be an interesting design problem, because they'd be living on the rim. If they wanted to have a constant, they wouldn't go 1G. Has anyone worked out the rotational speed that would be required to get 1G and for any given radius?
I don't know.
It's not that hard, but I don't.
No,
I'm not
I
sure
don't
what
know what it is either.
More than one rotation.
But would it matter? I don't know, because of course once you start it rotating, there's no cost in keeping it rotating, is there?
Right, that would not be the problem.
It's got to be big enough.
The geometry, yeah, the size and the geometry too. The guys on Skylab, in your introductory section there, you showed them running around the lockers up in the Skylab. And so that wasn't 1G by any means, but it was enough of a gravity.
For them to run, wasn't it?
And it's not gravity either.
No, but
yeah,
the effect is the same, isn't it?
The bigger issue is, when these guys get off the space station after several months, they're actually very weak. So if you're going to go all the way to Mars and spend many months going there in 0G and then land,
you're not going to do anything, are you?
You're going to just sit in your couch for a while. So I
it
think
it might even be a necessity then to provide the artificial gravity, using that as in the broadest term.
And the muscles and bone density and all that stuff.
Yeah.
Yeah, they might not be able to do it on the first trip to Mars. They might just say, "Hey, we got to live with this potential weakness when we arrive." But certainly, if it was to be done very often, they'd come up with some sort of way to create that artificial gravity.
Well, what's the longest?
I hate to even use that word.
No, I know, but it's providing the effect of gravity, isn't it? So it's giving you an up and a down with a 1G or 0.8G or whatever it is pull. You think, how long's the longest visit to the ISS? Is it about a year and a bit, maybe?
Yes. Yeah. It depends. As someone has a record for the longest time, I don't know exactly what, but it's at least a year.
Because, isn't that's a very short Mars trip? Isn't it closer to 18 months normally? I don't know. I'm just pulling things from memory.
Yeah, I guess there's like two options. I don't remember the details anymore, but you either stay a very short time, so you effectively just go there, stop, and come back, or if you stay more than a short time, you've got to stay for like 6 months.
Yes.
To get back. And I just don't remember what the mechanics are anymore.
So I'm just updating. I realised, I do apologise, at the bottom it says guests, Jeff, and I hadn't put Jim down. Sorry about that.
Well, he got big billing at the beginning.
He did get big billing at the beginning. Well, Jim, this is your third visit, I think, isn't it, Jim?
Yes. It is.
Because the first time we had those dreadful sound problems, and the second time we had it pretty much sorted out.
Right. Okay. Yeah. The first time I didn't have the little headphones and the microphone, so I was trying to use this phone speaker. So I bought this the second time, sat there with the phone in my hand for 3 hours. So my daughter bought me this, or gave me this nice tripod thing for Christmas so that I'd be prepared this time.
Oh, that's nice. Actually, how are your family? Because I've seen photos on your website, and I did put the link to your website earlier on in this stream. Yeah, so how's your family?
They're all doing well, even the extended family. my siblings are almost as old as I am.
Yes.
So they occasionally have problems. A brother-in-law broke his hip. A bull bumped the gate and knocked him down and broke his hip, but he recovered well from that. But my children all doing now is that they're trying to
Oh, Jim.
keep. They don't want us to go out.
Oh no.
This thing.
Oh, you two are back again. The problem must be at my end, internet connection at my end. I suppose it's a Friday night, it's late evening. A lot of people are watching stuff on the internet, I presume, and it's clogging things up a bit. I've probably got a slow connection tonight, so my apologies. But as long as we're getting things through to the stream, and the stream is looking all right, that's good. That's good. Where was it?
Let's see, interrupted back, but
It's okay. Oh, yeah, I've just got a message come up on my screen saying your network seems to be blocking a connection. So it looks like, oh, and again, I hope I don't lose this stream. I think I've still got you two guys anyway.
It seems to come and go.
It does, it does. Well, I've got nothing else running. Oh, someone said that I should give my end a wiggle and it might fix it. And the YouTube feed is okay. And Colon, you remember Colon, Jim? You chatted with him last time.
Yes, that's right.
He was just saying that, where is it? After 9 o'clock, it's Netflix time, and he's right. Everyone's watching rubbish on Netflix. Such a shame when we're having such a high IQ conversation here tonight, and I've really been enjoying it. I'm not a specialist of anything.
I have too.
Good, Jim.
I have a question for Jeff, though.
Go ahead.
And it may be the same thing that I've got into. How does geology and biology mix? How do you mix those two?
I was not really working on the biology per se. My interest was looking at the spectral properties. You know, you can tell the composition from the way the light gets reflected at different wavelengths. And so the real concern was from an exobiology standpoint. In other words, do these organisms have spectral signatures? Can you differentiate between organisms? After they die, does the signature remain? You know, because if we were going to look for them on Mars, we wouldn't be looking for live organisms. We'd be looking for some fossilized material. So I'm not a biologist.
Yeah, okay. Not a physiologist, but it was we had to learn physiology. I'm an electrical engineer, but I had to do mechanical systems. So I think probably nearly everyone runs into that sort of thing on the job. You just get a basic education and you learn the rest of it, or else you don't learn it, and you do something else.
Yeah, I've had to learn a lot of.
But I wondered. Yeah.
Well, Jeff, we were talking very briefly earlier when we did a test connection. And you were we were discussing, because you're talking about lasers. Sorry, is it I can't say the word. Spectroscopy of these hyperthermophiles.
Yep.
Yeah. About the fact it could be used in sensors, couldn't it? Perhaps from probes and stuff.
Yeah, I mean, we routinely make observations of the Earth and the other planets with spectrometers that look from the ultraviolet all the way out into the infrared, and different, from a geology perspective, different rocks have different absorptions. If you're a biologist, different kinds of plants have different absorptions, and gases have absorptions. So you can tell a lot about what's there just by looking at the spectra.
Because they use I can't say the word. It always spectroscopy. Is that right?
Yep.
Spectroscopy.
Yeah.
To try and to ID the constituent parts of other stars, and then when they get occulted by planets, the spectroscopy of their atmospheres.
Yes. And you can do that by, you take a spectra of, the star, and you just look at, and you can tell what kind of elements are in there. And you can also, if the star gets occulted, you can look and see if there's signatures from planets around them.
Which sounds absolutely phenomenal.
Yeah, that whole bit about detecting planets is, just incredible in terms of the, how complicated it is, and in a sense how limited it is, just because of the distances involved. NASA's made a lot of progress over the last 10 years in terms of detecting planets and planetary systems, and
because there's several ways, isn't there? Because you've got actual wobble on a star that can be detected, so you can see the gravitational pull of the planets, but you've also got the brightness, the magnitude of the star dropping as it gets occulted by a planet in a regular interval. And I'm sure there's other methods as well. They're discovering loads of extrasolar planets now, aren't they?
Yeah, particularly once you get out of the Earth's atmosphere with Hubble, and when Webb gets launched, they'll be able to find a lot more. Observing from the ground is kind of tough, because you've got the atmosphere in the way, and
a dome apparently as well,
and the dome. Any given observatory only really sees a small fraction of the sky. As the Earth rotates, you see the whole sky, but when you get towards the horizon, like looking to the north or the south or something, you look through too much atmosphere, so you're somewhat limited in where you can look.
Well, the thing I always find astounding is the Hubble Deep Space Field images, because they pointed at what they thought was a pretty blank area of the sky, a very small area of the sky, and just looking at those images and zooming in and seeing all those galaxies, it's mind blowing, isn't it?
And that field of view is, as I remember, it is less than the size of the moon. Against
I think it's quite a bit less, isn't it? It's not much at all. Yeah.
Yeah, there's a lot of stuff out there. Yeah. You need to get somebody on who does deep space cosmology.
Well, if you can name anyone or point someone my way, I'll happily do that.
So I looked up while we were talking. The record holder for the longest duration in space is a Russian, Polakov, 437 days.
Wow!
Back in 1994 on the Soyuz.
Oh, so that's quite a while back, wasn't it?
Yeah.
So you can imagine if he was there in microgravity for all that time. He would have been absolutely useless for a while when he came back to Earth. I can't even imagine what that would feel like.
Yeah, I can't either.
Well, bed rest studies are the thing that helps you understand what happens and what you can do about it. Things that increase your circulation while you're lying in bed. We used to know of a lot of bed rest studies going on at the Johnson Space Center.
You mean you were all sleeping on the job, Jim? Were you just all sleeping on the job?
The only thing I volunteered for was that one spacesuit test. That was it.
Oh man, I would so love to do it. I'm honestly so jealous. I really am. If they turned around to me and said, "Look, do you want to do it? You're going into hard vacuum. Do you want to do it?" Maybe I would. I would be really, really scared. But wow, what an opportunity! It really is. Well,
maybe we could send one of the
yes, without a suit. Try this hard vacuum. There's no such thing,
Well,
is there?
It would be neat if they could try it, but yeah, it's expensive.
Yes. I wouldn't waste it on them.
You know, who was the guy who did that high altitude jump?
Felix Baumgartner, something like that.
Yeah,
The one
and
from the
that
Red
flight
Bull.
is known by the sponsor Red Bull.
Red Bull,
Yes.
yeah.
A guy called me back in the 90s, maybe between 90 and 95, in that time period, and asked what he would need to make a jump like that. I don't know if it's the same guy or not. I'd forgotten by the time this came around. He said he thought it would work if he just got into kind of a wickering and launched and made a real fast trip up and jumped out before anything happened. I said, no, you're not going to do that. Besides, it's cold. You have to have, you have to have pressurized oxygen at that altitude.
In
But
effect,
anyway,
he was wearing a spacesuit, wasn't
you
he?
can tell from that capsule that they had and the capsule that he was in, that was an expensive proposition. So you're not going to get many opportunities to even do something like that, let alone pay to get a suborbital flight. But yeah, and the same thing with the chamber. You got a lot of people and a lot of overhead. Once the system is there, it costs that much to run a test, but it's expensive, and you can't take time. It's like doing astronomy. You've got limited numbers of telescopes,
Yeah.
limited amount of time to use them, and so you can't just let anybody go up there and look at a star. You can't just let anybody get in a spacesuit and have fun.
Yeah. Yeah, it's got to be a valid reason. So, I mean, the fact you had that opportunity is wonderful, isn't it?
Yes. Yeah.
You've been living off that story for all the years since, Jim.
Yeah.
Yeah. I'll tell you a story. You buy me a beer.
Appreciate what was involved.
Wow. I mean, I'm glad you got that photo that we showed earlier. Well, where are we? Time-wise, 11:15. I do apologise. That caught me by surprise. Just time is getting on a bit. We started a little earlier because I was expecting Jim to come in at 10. But I'd started the stream at 9:30 because I just thought, wow, this is usually a bit of chatting and that. And lo and behold, Jim was there. Jeff was already there. So, in effect, we started half an hour early. So, what's that? I can't think. 9:30, 10:30, nearly 2 hours.
Yeah, it's been fun.
It has. I'm glad you've enjoyed it, Jeff. When I got talking with Jeff, Jim, on email, I suddenly thought, do you know what? This could be an interesting combination of things to, people with things to talk about.
Yeah, it was.
Yeah, well, I'm glad, Jeff.
Right. It's interesting. Let me put in a plug for Houston.
Go ahead.
We have, I live south of Houston. Balmy atmosphere, a lot of humidity, but if you love the sun and the humidity, it's a great place to live, and we've lived here for 50 years. So
I wouldn't say no, Jim.
We prefer that to the cold north. What?
I wouldn't say no. I'd happily come there.
We just saw a brother-in-law in Chicago. I have a brother-in-law in Chicago,
Yeah.
and the big expressway up there was like a 50-car pileup because of snow. Snow in the middle of April. Snow here this year. This part of Texas is more like Florida was in the 60s. That's how much warmer it is than in the 60s.
You've noticed the climate change.
I certainly have.
Yeah. I mean, for me, I remember when I was a kid, there was never lots of snow in the area of England I lived, but nearly every winter you'd get a few snowfalls of a few inches. Now, past winter we had one brief flurry of snow. The winter before, maybe a day or two with snow that was gone the next day. Nothing really.
Yeah, the same thing here in the northeast part of the U.S. When I was little, we had lots of snow. Now, not so much anymore.
It's not good, is it?
Global climate change.
I like the warm weather.
Yeah.
But I know it's going to be bad for us one of these days. I'd hate to get cold again, but we need some balance.
Yeah, well, some places are meant to be warm and some places are meant to be cooler. It's the sudden change which isn't good. I mean, nature can't adapt that quickly. If you're talking over just our lifetimes, a noticeable change. Well, I suppose animals can move at a certain speed, but then things like forests can't move at all. Not good.
Right.
Oh, this is on a downer. I don't want to end on a downer. I've really enjoyed tonight.
No, sorry.
But, maybe we should start to wrap up. Unless anybody in the chat has any last questions to ask either Jeff or Jim, please shout out now or forever hold your peace. It'll take 30 seconds, I think, for the chat to come through. A lot of people made comments about your cat, Jim. He's in and out like nobody's business.
Well, this is another cat.
Oh.
This one is.
And my cat, Arnold, is kicking around somewhere.
Our daughter just recently moved to a new home, and she had rescued a stray cat and took it with her. It lived in the backyard, and then the little teeny kitten strayed into their backyard. She finally got it tame enough that she could pick it up and put it in a carrier, and she brought it to us because we needed one more cat.
How many you got?
And, well, we have 3.
Yeah.
The city ordinances say you have a maximum of 4.
Oh. Here, there's nothing like that.
Well, this is because of dogs. You could have a maximum of 4 dogs. The dog people said, wait a minute, that's not fair. Limit the cats as well. When we moved here, there was a rule that the dogs could follow people from out of the country into town, and that was okay. They could run loose if they were following their owner into town from the countryside. But the other dogs the city dogs had to stay in the yards.
Well, it's all different. I mean, here you can have as many as you want as long as you can show that you looked after them. We've currently got 2 cats and 2 dogs. And I've got 2 tanks of fish. Used to have chickens, used to have a snake, used to have a bearded dragon, used to have dagoos, used to have hives of bees. Had pretty much everything, really, over the years.
Are you in more of a rural area?
Yes, live in a small... I was born in and grew up in a city, always wanted to live in a village. My wife grew up in a city, always wanted to stay in a city. So when we got married, we were living in a small town. And when we looked to move to a bigger house, I wanted to move to the country. She wanted to stay in the town or into a city. And the only fair thing to do was to look at both. And we actually both agreed on this one. So it's tough. We had to do one or the other. You couldn't do both, obviously.
Yeah. How big is the village?
But at least you agreed.
We did agree. Yeah, I think it's about 200, 220 houses. But of course, our houses are a bit smaller than American houses. There's smaller amounts of land. Although mine's not bad. I've got a reasonable amount of space. But it's pleasant. I mean, I back onto fields. Across the road, there's a house, and then there's fields behind that. 2 minutes walking, I'm out in the countryside. 30 seconds drive. So I'm happy with that.
Yeah.
Anyway, I think we've probably covered just about all sorts of things. I think if you two guys are happy, I'll wrap it up. And I don't know if you've got any last words to say. Have you anything, Jeff, to say?
No, thanks very much for the chance.
Oh, my pleasure.
Nice chatting with you, Jim.
Oh, I've enjoyed the time and hearing about a completely different field from what I was in, at least with what Jeff is doing.
Yeah, it's fascinating stuff, isn't it?
No, I will say that I have high hopes for the lunar mission. From experience, I've found normally you cannot move the schedule up, but maybe they will.
Oh, he's locked.
I'll get to see that.
Oh, yeah.
Okay.
I certainly hope so. Well, let's just hope, Jim. Let's just hope
see what happens.
That they've still got the right stuff. Oh, we lost that. Both connections now. Oh, no. Oh, they're back again. Yeah, I've got network problems. You can see that actually popping up on the screen. Okay. I think at this point I shall thank Jeff, who's pretty much a last-minute guest. It's been very welcome. It's been most enjoyable, Jeff. It's been great talking to you, and it has been great hearing about different things. So I really, really appreciate you coming on. And thank you again, Jim. And please thank Mrs. Skip for allowing you to spend the time here. I've really enjoyed it. It's great to see you keeping your health, and I trust that, well, both of you keep safe and well from this COVID thing. And me.
Yeah, you do.
Yeah, I'm trying to.
Yes, you too. All of us.
So I'm going to thank you both. What I'll do is I'll just mute you. Be welcome to stop around for a minute. Oh, we just had a super chat come through. I'll read it out from Crafty Keeler, who super chatted €2. Said, "Thank you, Jim and Jeff. So much respect for both of you."
Oh,
it's nice, isn't it?
Thank you.
I appreciate that.
And actually, I will just take the opportunity. Keeler has keeps goats, and yesterday there were 2 goats born, and I've been asked to name one. And you can you can see the goats on her channel, which is called Crafty Keeler. That's with K. You can see the name there on the super chat. The channel name's the same, and you can see the goats. And I've been asked to name one, so that's something I'm thinking on, Keeler. Thank you, everybody, for the super chats, for joining in the side chat. It's been great. I've loved this, and hopefully, Jim and Jeff, we can do something like this again. Either all 3 of us or a different combination, if you're up for it.
Sure.
Excellent. Excellent.
Yeah, I will be.
Good stuff, Jim. I'll look forward to it.
Yep.
Okay, and you keep in touch with email.
No,
yeah?
okay.
Okay. So thank you, everybody.
All right.
Really, really
Goodbye,
appreciate you
everybody.
coming. Take care. Bye-bye.
Bye. Grrr.